Okay, so in the last two videos I discussed Charles's law. In this video I'm going to describe Avogadro's law, or avocado as we call him in class. So Avogadro's law, this is what he's saying in his law. If you take 1 mole of oxygen gas, it's going to have this volume right here. Okay? We dump twice the amount of moles of gas. We put more gas molecules into this balloon. And what happens to the volume? Oh, it increases. Oh, well, we can graph that. We can say at a certain volume, we're going to have a certain amount of moles in our container. And then we increase the volume. Oh, the amount of gas we have in there is going to be increased. Or we can say we added moles of gas to our container and the volume increased. And remember, this is under constant pressure and temperature. Okay, so P and T are not changing. Alright, so this is Avogadro over here. Charming fellow. Let's put this, let's get an equation going here. So, like, just like in Charles's law, we had to use mx plus b, y equals. We had to use the slope-intercept form to describe this line here. And for our y, we're going to have v. For our slope, we're just going to have this constant k. For our x, we're going to have n, the number of moles. Not m, but n. And right here, where we're meeting our y-intercept, we are at 0 moles. And that makes sense. If we have 0 volume, we have 0 moles. If we have no gas in our container, then the container's not going to have any volume. Okay, so what the book does, it just knocks off the 0, and they give you V equals Kn. And then they say, okay, well, we can write this equation for each point. So V1 N1, we can go V1 equals K N1, and then they rearranged it to where it's V1 over N1 equals K. And extend my page here because they divide by N on both sides. And then this is what they get. And they do that because then they can say, okay, well, V2 over, it can work for any point I have up here. So V2 over N2 will equal K. Oh, well, yeah, it will. So now I can look here. Oh, if V1 over N1 equals K and V2 over N2 equals K, then I can just say, let me do this the fancy way here. I can just say, it's going to make me move everything. Oh, yeah, it's 1 unit. I can just say that V1 over N1 equals V2 over N2. And that is our final equation for right now for Avogadro's law. Let's put that to use. So we're going to have an example problem. Example problem with Avogadro's law. Suppose we have a 12.2 liter sample containing 0.5 mole of oxygen gas, O2, at a pressure of 1 atm and a temperature of 25 degrees Celsius. If all of this O2 is converted to ozone, O3, at the same temperature and pressure, what will be the volume of the ozone? So let's write out the things that we need. We have a volume there. We're going to write out our knowns and unknowns. So V1, I'm going to call this V1, equals 12.2 liters. And then it contains that many moles, so that's my N1. This volume I have 0.5 mole. And then I read on, pressure of 1 atm. I can write that down. Pressure 1 equals 1 atm. Well, I read, so my pressure is 1 atm. I read later and we have the same temperature and pressure, so this also equals P2. So P1 equals 1 atm and so does P2. same pressure. Okay, and a temperature of 25 degrees Celsius. So my T1 equals 25 degrees Celsius. But again, we have the same temperature. Temperature stays the same, so does the pressure. So my T2 is also that. So I know I'm using Avogadro's law because V1 and N1 will change. We read on, at a pressure of 1 atm and a temperature of 25 degrees Celsius, if all of this O2 is converted to ozone, O3, at the same temperature and pressure, what will be the volume of the ozone? So they're kind of hinting that we're going to have a V2. That's what we're looking for. Here's the hard part about this problem. What is N2? Well, I don't know what N2 is, but we can find out. We can find out. Okay, so if we have 0.50 mole of O2, what if we cut these O2s in half? It's O bonded to O. What if we cut them in half? How many moles of O would we have? Well, we're doubling, right? We're doubling them out. If I come along and break this bond, and now I just have O's and O's. So here I had one O2, now I have two O's. Well, it doubled, right? So I can just double the amount of moles, right? If I just had O, I'd have 1.0 mole of O. Well, we can go in the reverse of that. Let's say we take two O2s and attach another O to it. And that's what we're doing in the sample. We're converting the O2 to O3. So we're taking this, adding an oxygen, and making O3. Okay, well, I would then have, okay, if I, so let me draw this out. If I have 3 oxygens, and so that's 1. If I pair them, or that's 3, sorry. If I pair them all up, then I have 1. So it's a 3-to-1 ratio. So if I have 1 mole of just O, then I'm going to have a third of that for O3. So I'd have 0.33 mole of O3. Alright, so hopefully that makes sense to you. But this is our N2 right here. 0.33 mole. And if it doesn't make sense, come ask me during class. I'm running out of video time, so I'm speeding along with this one. Alright, so I have V1, I have an N1, I have an N2, I need V2, so I'm using Avogadro's law, which is V1 over N1 equals V2 over N2. And I need to rearrange the equation to solve for V2. Well, to do that, you're just going to use your algebra, right? You're going to multiply both sides by N2. N2 divided by N2 is 1, so we get rid of that. Now our equation is nice. It's solved for V2, which is what we want. V2 is all by itself on one side. That's exactly what we wanted. So V2 will equal, I'm going to plug in the numbers here. V1 is 12.2 times N2, which is 0.33, divided by my N1, which is 0.5. Extend the page down. So I have 12.2 times, clear this, 12.2 times 0.33 equals, divide by 0.5 equals 8.0. How many sig figs do I need? I have 3 there, or 2 there, 2 there, and there's 2 for the moles and the, yeah, 2 sig figs. So I go back to my calculator. You make this 2 sig figs, so it's going to be 8.1. Everyone, you see that? The 5 makes the 0 go up to 1. We round up. Okay, 8.1. Oh, what's my units? Well, look back up here. The volume was in liters. We solved for volume, so this is liters. And we can check ourselves. We can look at the math here. if I take N2, which is moles, times V1, which is liters, and I divide by N1, which is moles, I have mole divided by mole, those cancel out, I have liters left, and that's what I want for my volume, is liters. And there we go, we solved it. Notice, they gave us a pressure and a temperature. They are going to do that. Go ahead and write it out, but you're going to see if you write everything out that you didn't need them. P1 equaled P2. T1 equaled T2. So we really didn't need to use them in this case because we had V1, N1. V2 is what we were solving for, and we had N2.